Hello everyone, welcome back to Pre-Algebra with Miss Betsy. I'm glad you're here to join me for this just fantastic journey into wonderful world of Pre-Algebra. And now that you know I've surely lost my mind, I'll follow that up with confirmation by reading you this lame joke. What has 100 legs and pointy toes? It is a centipede doing ballet. We're in section 4.3 today. We're talking about subtracting integers. I'm using as my text Pre-Algebra for Christian Schools by Bob Jones University Press. You can use any pre-algebra text that you wish. Subtracting integers is subtracting integers no matter what country you're in, no matter what text you're using. So, as a review, what we have with integers are positive numbers, they're negative numbers, and they include 0, and they're whole numbers. It's not fractions, not decimals. It would the way that you would define or describe the set of integers using Setbuilder Notation is you have the ellipses that says the pattern continues in the negative direction. 0, 1, 2, and then the pattern continues on towards infinity in the positive direction. So you can almost think of the set of integers as being counting numbers, 1, 2, 3, 4, 5, 6, 7. Negative counting numbers are the opposite of counting numbers, which are the negative 1, negative 2, negative 3, plus 0. 0 itself is neither positive nor negative. So what we're going to be talking about today is how do we subtract integers. You know how to subtract 3 minus 2. You've learned that a long time ago, that 3 minus 2 was equal to 1. And it's a very simple process for you. You do it intuitively. But what happens when we have something like when we add integers and we say, well, I was going to say 3, but I guess I'll say 2 minus a negative 1. How do you subtract when you have negative signs? It was very easy to do. 2 minus 1 would be equal to 1, but we're not subtracting 1. We're subtracting a negative 1. So there has to be a different way of approaching subtraction when you're dealing with integers. And they want to show us how to do this, even though a lot of you probably already do understand how to subtract integers. I want to say one thing with a minus sign. You've noticed this in class. I might say something like the opposite of x is equal to 2. Well, you say, is that a minus x or is it an opposite x? Well, the minus sign can be used to indicate several things. And I'll just say the minus symbol. Too early to spell. Minus symbol can mean subtract. It can also mean negative. And it also can be read the opposite of. So that's just a reminder that whenever you see that little dash, that doesn't just mean minus. Okay, I can say I'm taking the opposite of something, and remember we've talked about what opposite is on a number line. The opposite of a number is going the opposite direction on the number line, the same distance from 0. Let me draw that number line for you right quickly here as a reminder. Our number line has to have arrows on both ends. That the arrowhead indicates that that pattern continues on forever. In the positive direction to the right, and in the negative direction to the left. And if we have a number here, which is 2 units from 0, in the right-hand direction, we indicate that with this dot here, that we're at the point positive 2 on the number line. We know it's positive because there's no sign in front of it. What is the opposite of 2? Well, how far is 2 from 0 on the number line? It's 2 units. Well, its opposite is the same number of units from 0 on the number line in the opposite direction. So the opposite of 2 is negative 2. So what do we get if we say, instead of starting at 2, we're going to begin with a negative 2. And then we're going to say, okay, I want to know what the opposite of negative 2 is. So we're going to say, what is the opposite? The opposite of negative 2 is what? Here is negative 2. It's 2 units to the left of 0 on the number line. Its opposite is going to be 2 units to the right of 0 on the number line, which is a positive 2. The opposite of negative 2 is equal to 2. So just a little bit more vocabulary here. Now, look at these 2 examples here. I want to show you, we have subtraction here. Three minus 2 is equal to 1. Never believe that 3 minus 2 is equal to 1 would be in a pre-algebra class, right? Subtraction. What about addition? How can we do that same thing? Well, we're going to add the opposite. So we're going to begin with a 3. Instead of subtracting a 2, we're going to add the opposite of 2. Now some of you have learned to write this instead of having a negative 2 in parentheses. You might have said 3 plus the opposite of 2. This messes with my mind, it gets me confused. When I put parentheses around it, it helps me to see more clearly what's going on. You need to do whatever works best for you. In section 4.2, we were talking about how you add signed numbers. Integers are signed numbers. They're either positive or negative. If you have the same sign, 2 plus 3, it said add their opposite values. Opposite values? Add their absolute values. So the absolute value of 2 is 2, the absolute value of 3 is 3. And keep the sign of the addends, which is like, well, that's really dumb because I really do know how to do 2 plus 3. I don't have to do anything silly here called adding absolute value because I know how to do this. Well, but then it becomes, okay, what do you do if you're going to add a negative 2 plus a negative 3? And many of you can automatically look at that and remember and know that that's a negative 5. But when you're beginning to learn how to add negative numbers, you think, I'm just really not quite sure what's going on here. And this is when our definition for adding signed numbers comes in real handy. It says, take the absolute value of those numbers. Absolute value of a number is always positive because absolute value is the distance from 0 on the number line. 2 plus 3 is equal to 5. Are we finished? No, because the first step is add their absolute values. The second step is look back at the original problem and use the sign of the addends. This is a negative 2 and a negative 3. The sign is negative. So the solution here is a -5. So that was what we did when we were adding signed numbers that were either both positive or both negative. Then what we had to do when we had, what happened when we added differently signed numbers, which is what we have here. We have a +3 and a -2. Well, what we did was we subtracted the absolute values of those numbers. 3 minus 2 is equal to 1. And then how do we know if it's a positive or a -1? We use the sign of the addend that has the larger absolute value. What that really means, the way most kids' minds work, most adults' minds work, is, okay, that number there, the 3 is bigger than the 2, so I'm going to use that sign. So if you had a -3, let me not even do it this way. Let's say that you had a 2 plus a -3. What are you going to do? You're adding signed numbers. You subtract their absolute values. 3 minus 2 is 1. But you use the sign of the number that looks bigger. 3 is bigger than 2. It has a negative sign. So your answer there is a -1. Okay? What I'm wanting to show you for this subtraction and addition of adding the opposite, two different approaches, you get the exact same answer. You have to, because of the fact that it's the rule, it's the pattern, it's the consistent thing in pre-algebra, the consistent thing in math, period. So what we're going to use when we subtract integers is this concept that you can add the opposite, that subtraction is the same as adding the opposite. So they're going to ask you to rewrite subtraction problems as add the opposite. I'm looking here in my text on page 120, and the first one that we want to rewrite is 9 minus the opposite of 7. This is how your text is going to use it. Right, I can't do it that way, I'm sorry. 9 minus a -7. We want to rewrite that as, instead of subtracting, we're going to add the opposite. 9 plus, what is the opposite of -7 on the number line? It's a +7. 9 plus 7 is 16. Now here, when they say rewrite the problem as in adding the opposite problem, this is all you have to do. They're not asking you to solve it. They're asking you to rewrite the subtraction problem as a problem where you add the opposite. If we have -5 minus 9, it's a subtraction problem. We want to rewrite that so that we add the opposite. -5 plus the opposite of a -9. Do I mean that? -5 plus the opposite of 9. So this is, we have to be careful with this. What are we subtracting? We are subtracting a +9. So what do we have to add? You have to add a -9. What we're doing now, and this would be your answer, you've rewritten this as a problem where you're adding the opposite. What would this solution be? You're adding two numbers with the same signs. You add their absolute values, 5 plus 9 is 14, and you take the sign that's being used. So -5 plus a -9 is a -14. Now, what they're teaching you here is simply, if you want to subtract integers, you can add the opposite. 8 minus a negative 5. Change that into an addition problem. Instead of saying subtracting something, we are going to add its opposite. We were subtracting a negative 5. We're going to add the opposite of negative 5, which is a positive 5. 8 plus 5 is equal to 13. Now, let's say that we're going to evaluate. This says evaluate negative 7 minus n for n equals a negative 3. For n equals a negative 3. What do? We just substitute the negative 3 for the variable. We have negative 7 minus negative 3. Make sure that you're using your parentheses, that you're careful that you substitute in exactly what it's telling you to. I promise you that mistakes that people make are not frequently not for lack of understanding what's going on. It's for not being careful to keep your negative signs. We change this to an addition problem where we're adding the opposite. Negative 7, instead of subtracting a negative 3, we're going to add the opposite of a negative 3, which is a positive 3. Now we're adding differently signed numbers, adding unlike signs. We have a negative 7, we have a positive 3. What did we learn to do with that? Subtract the smaller number from the bigger number. When I say the smaller number, I mean the smaller absolute value from the larger absolute value. 7 minus 3 is 4. Now we have to make sure we're using the correct sign. What is that correct sign? Well, the negative sign in front of the larger number is a 7. So negative 7 plus 3 is a negative 4. If this is a little bit awkward to you right now, that's normal. You're just learning it. But very quickly it will become second nature to you so that you know negative 7 plus 3. You're automatically doing all of these conversions in your head and you're saying, oh, when I'm just subtracting, but I'm using the sign of the number that looks bigger to me. It becomes a very, very straightforward operation. Let me pull an example that looks like it should be really, well, let me do an easy one first. 15 minus a negative 8. Your instructions here simply say subtract. Minus a negative is to add, but some of you have already learned that. But here, let's say I'm still struggling a little bit, or I'm just beginning to learn how to subtract negative numbers. Subtraction is the same as adding the opposite. 15 plus the opposite of negative 8 is a positive 8. So your solution is 23. What if we have 47 minus 63? 47 minus 63. Subtraction is the same as adding the opposite. 47 plus the opposite of 63, which would be a negative 63. And now we kick in the rule for adding unlike signed integers. When you're adding integers that have different signs, what do? You subtract the smaller number from the larger number. Their absolute values is what you're actually subtracting. 63 minus 47, you've got your work over to, or your scratch, over to the right-hand side of the page. 63 minus 47 is 16, right? And then, because the larger absolute value number has a negative sign, you take its sign, so you have negative 16. Very, very straightforward. Just be careful when you substitute in to evaluate that you are using parentheses to indicate for sure that you've got a negative number. We do one more example for you. Let's say number 24. This is negative 18 minus n for n equals a negative 3. What are we going to do here? Substitute the negative 3 in for the variable n in our problem. Negative 18 minus, in parentheses, negative 3. It jumps out at you that you are subtracting a negative number. Subtraction is the same as adding the opposite. Negative 18 plus the opposite of negative 3 is a positive 3. Now we're at our rule for adding integers. When we have differently signed integers, we have a negative and we have a positive, what do? You subtract them. I have to say you're subtracting their absolute values, but you're subtracting them. 18 minus 3 is 15. The negative sign is in front of the larger number. The negatively signed number has the larger absolute value. So you use its sign. And that's all there is to subtracting integers, and I'll see you next time.